Over 2 billion tons of waste are produced by humans each year. Glass makes up nearly 20% of that total waste. A single glass bottle can sit in a landfill for over 1 million years.
It remains without breaking down.
But here's the good news. Glass can be recycled forever without losing quality.
So how does that process actually work?
How do messy, broken shards get reborn into clean, shiny bottles? Let's step inside one of the world's largest glass recycling factories. Hundreds of tons of glass are brought back to life every single day. To recycle glass, the first requirement is a steady supply of used bottles.
In daily life, empty beer or soda bottles are often tossed together with regular household trash.
This makes sorting for recycling costly and complicated.
Many European countries have designed systems to handle this problem right at the source.
Glass bottle return machines are installed across city streets.
Consumers simply place an empty bottle into the machine.
It scans it, sorts it, and gives back a small refund.
Usually around 10 to 20 cents per bottle.
This means a freshly finished beer bottle instantly turns into a valuable asset.
This approach motivates people to collect bottles on their own.
It also provides factories with pre-sorted, clean, and consistent glass.
Europe seems to have it all figured out.
When the reverse vending machines are full, collection companies send out specialized trucks. Large plastic bins, each holding thousands of empty glass bottles, are loaded onto trucks.
A single full-size truck can carry between 20,000 and 30,000 bottles, equal to about 10-12 tons of material.
Trucks loaded with glass bottles quickly make their way to the recycling plant. When they arrive, drivers back up to a massive storage bay and release the load,
sending a cascade of bottles tumbling down.
In just minutes, the ground fills with colorful mountains of glass that sparkle. Greens, browns, and clears stacked together.
These piles aren't just waste. They're the starting point of the recycling chain.
A steady supply of raw material waiting to be cleaned and crushed.
To kick off the recycling process, massive loaders drive up to the towering piles of waste glass.
They scoop up huge loads with their buckets and carry them across the yard.
With a thunderous crash, the glass is finally dumped into the plant's feed hopper, sending a cascade of shards down the steel chute. Instantly, the steel conveyor starts moving, carrying the stream of glass mixed with dirt and sand.
The first stop is the vibrating screen, where powerful shakes separate out dust, grit, and tiny particles. After this stage, the glass is much cleaner. But larger contaminants that machines can't easily detect still remain. Along the conveyor, workers stand ready, carefully pulling out paper, plastics, and anything else. This blend of mechanical screening and human hands produces a cleaner batch of material. Ready for the next step in the recycling journey. Do you know what's still hiding in that pile of broken glass? The bottle caps.
Luckily, most of them are made of metal.
They can be pulled out easily with a high-powered magnetic separator.
The strong magnetic field grabs the bits of steel while the glass keeps moving.
Thanks to this step, the glass is now about 80% clean.
And one step closer to its journey of rebirth.
Once most of the contaminants have been removed, the glass moves on to the next crucial step: being ground into cullet. The larger pieces are fed into a hammer mill, a massive machine with high-speed rotating hammers that smash the glass over and over until only tiny fragments remain.
Any pieces that are still too big are automatically detected and sent back through the mill
until they reach the right size. This makes sure the entire glass stream is uniform, with no stragglers slipping through.
The process creates cullet, fine, sparkling glass particles that look almost like man-made sand.
Because it's broken down so small, cullet melts much faster in the furnace, saving up to 40% of the energy compared to using raw materials like sand or limestone.
After that, the cullet is carried to a powerful suction system,
where it's blasted with a strong stream of air. This airflow strips away and blows off any leftover label fragments, leaving the glass even cleaner.
Finally, the cullet moves into the optical sorting system, the most precise step in the process.
As the glass cascades down like a shimmering waterfall, laser sensors continuously scan each tiny fragment
to detect its color and composition.
The moment brown glass, green glass, or even a stray ceramic shard is identified,
the system instantly fires a precise puff of air, shooting it into a separate stream. The speed is almost unbelievable. Tens of thousands of pieces are processed every minute.
This ensures that the cullet is sorted with perfect accuracy by color, because even the slightest mix of the wrong shade would ruin the quality of recycled glass. Once the cullet has been sorted, it continues moving along the conveyor belt. The tiny glass particles are directed into separate storage areas, each divided by color. There, they gradually pile up into massive stockpiles, waiting to be transformed into brand new bottles. After being sorted and ground down, cullet can't go straight into the furnace on its own. The mix starts with pure silica sand, the key element that gives glass its clarity. Then comes soda ash, or sodium carbonate, which lowers the melting temperature and saves energy. Limestone is added as well, strengthening the glass and making it more stable once formed. Manufacturers also include dolomite, alumina, or metal oxides to adjust color and properties. The most important part, though, is still the cullet, which can make up anywhere from 20 to 70% of the batch, allowing the melt to flow faster and cutting energy use by up to 40% compared to brand new raw materials. Adding just 10% more cullet can reduce energy consumption by about 3% and significantly cut CO2 emissions. With the predetermined formulas from the factories, the mixture is mixed evenly
And ready for the melting process.
The blended mix is then fed into a massive gas furnace, where temperatures reach about 1,500 degrees Celsius.
Even hotter than molten lava from a volcano.
Technicians carefully monitor the entire process and pour the mixture into special crucibles. Inside the facility, workers must wear fireproof suits and heavy gloves, as the surrounding heat, nearly 3,000 degrees, is almost unbearable.
Once the ingredients stabilize, the mouth of each crucible is sealed to maintain the extreme heat and control the melting process.
After 24 hours, the mixture is no longer sand. It begins to flow thick, like lava.
The brilliant glow at the bottom of the furnace is liquid glass. A dense, shining mass that has reached the perfect temperature and viscosity. For the next 5 hours, the glass remains in its molten state,
allowing any remaining gases to escape and ensuring the highest purity in the final material.
To shape glass, a mold is required.
Which makes mold creation the next step in the process. Engineers use advanced CAD software to design the mold with high precision, carefully controlling every line, dimension, and thickness to meet technical standards. From this digital design, molds are manufactured from cast iron or alloy steel, capable of withstanding temperatures of up to about 1,400 degrees. These molds are then prepared to receive the molten glass and form it from the inside. Once the molds are fully completed, they are carefully installed into the double-blow production line,
One of the most widely used and reliable methods for shaping hollow glass products, such as soft drink bottles, food jars, and pharmaceutical containers.
The forming process begins by dropping molten glass, known as gobs, into the initial blank mold. These gobs are cut from a continuous stream of liquid glass, reaching temperatures of around 1,100 degrees Celsius,
and have the perfect viscosity for smooth and consistent shaping. Inside the preliminary mold, a jet of compressed air is blown in from above,
pushing the hot glass outward against the mold walls. This forms the initial shape, known as a parison.
Still glowing with intense heat, the glass is gently transferred to the final mold. Here, a second burst of compressed air is shot directly into the center of the parison.
Stretching the softened glass outward until it presses tightly against every contour and detail.
In just a matter of seconds, the full shape of the bottle takes form.
It may look quick and effortless, but every valve and sensor is timed with incredible accuracy.
Synchronized down to 1,000th of a second.
This extreme level of control makes it possible to manufacture hundreds of thousands of bottles per day, each one nearly identical and flawless, as if they all came from a single perfect mold.
Just released from the oven, the glass bottles radiate a deep red heat.
Their surfaces shimmering in the dark, as if they were glowing metal rods.